Hello, my beautiful viewers. You're welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we'll be solving this beautiful integral. So integral from 0 to 1 of x raised to the power 4 plus 4 over x raised to the power of 2 plus 2x plus 2 dx. Okay, guys. So if you're new in this channel, please don't forget to subscribe to my channel, like my videos, comment, share, and click the notification button so that anytime I upload video, you'll be the first to watch. Yeah. So how do we solve this beautiful integral? Hmm. So if you know how to solve this integral, you can just pause and then solve it, and let's see what you get. Okay, so let's dive into the solution. So guys, I will be using a beautiful identity here, which is the Sophie Germain identity. Okay, so using the Sophie Germain identity, and here is the identity. So if we have a raised to the power of 4 plus 4b raised to the power of 4, so this will be equal to a raised to the power of 2 plus 2ab then plus 2b squared, then multiply by a raised to the power of 2 minus 2ab plus 2b squared. Okay, so that's the Sophie Germain identity. All right, so I can now rewrite x raised to the power of 4 plus 4 in this form. So that shows that here a will be equal to x and then b will be equal to 1. How? If you write this means x raised to the power of 4, then plus 4 multiplied by 1 raised to the power of 4. So that shows that a is x and b is 1. Okay, so then we can now have this. So we can now have x raised to the power of 4 plus 4 equals, so that will be x raised to the power of 2 plus 2x plus 2, then multiply by x raised to the power of 2 minus 2x plus 2. Okay, so that is x raised to the power of 4 plus 4. Okay guys, so let's move on. Since we've factorized x raised to the power of 4 plus 4, so we should be able to solve the integral, which is, right? So the integral becomes integral from 0 to 1. So instead of writing x raised to the power of 4 plus 4, so we're going to write x raised to the power of 2 plus 2x plus 2, then multiply by x raised to the power of 2 minus 2x plus 2, then everything over x raised to the power of 2 plus 2x plus 2 dx. So clearly we can see that x raised to the power of 2 plus 2x plus 2, we cancel this. So what we have now is integral from 0 to 1 of x raised to the power of 2 minus 2x plus 2 dx. So this is beautiful. Okay guys, so we have integral from 0 to 1 of x raised to the power of 2 minus 2x plus 2 dx. So then if you integrate this will be equal to integral from 0 to 1 of x raised to the power of 2 dx minus 2 multiplied by integral from 0 to 1 of x dx, then plus 2, then integral from 0 to 1 of the x. So, and remember that if you have integral x raised to the power of n dx, so this will be equal to x raised to the power of n plus 1, then over n plus 1 plus c. Okay, so then we're gonna solve this integral using this formula. So we're gonna have x raised to the power of 2 over 2, then from 0 to 1 minus 2 into bracket x raised to the power of okay, sorry, this will be 3 over 3, so minus 2 multiplied by x raised to the power of 2 over 2, then from 0 to 1, then plus 2x also from 0 to 1. So this will give us 1 over 3, then minus 2, then into bracket 1 over 2, then plus 2. Okay, so 2 we cancel out to here. So what we have now is 1 over 3, then minus 1 plus 2. And this is going to give us 4 over 3. So that's the answer to that beautiful integral. Okay, guys, so that will be the end of today's video. All right, guys, so please don't forget to subscribe. Don't forget to like. Don't forget to comment and share. Thanks. See you next time.